I just put this piece of 2-inch PVC on the top there, pushed, and bearing went back down, but I think it took the it took the shaft down with it. Shaft's still not up. So here's the conundrum. When I push up on the shaft here, it's pulling the bearing up. So what I've got to do is I've got to figure a way that I'm going to put this back down like this. How about this? What if I flip the whole darn thing over on the bench? And now I just need to push that down. Need something. Need something. Just occurred to me, maybe now would be a good time to put that whole bearing, lower bearing pack in here. Make sure that all gets lined up. In other words, I need this to go in just right. Put the high spot of that shaft facing up. So that means this low spot of the shaft on this side will face up. Alright, now you get this bearing, this upper bearing that moved up back down. But I want to push only on that inner race. Technically, it's a loose fit in the outer bore. It's a tighter fit on the inner bore. So yeah, I want to push only on that inner one. So I don't want to use this because this will only push on the outer. Yeah, that's going to be putting too much force. So I need something with a diameter that's going to be able to slide over this. Looks like this piece of 1.5 inch PVC is going to work out diameter wise. You want to do that? What do that for? Alright, so what I need to do is get this thing on the floor because my PVC pipe's a little longer. Let's see if that'll just tap down, or if I'm going to have to put this in the press, then I'll have to cut a sleeve of this PVC. Got some threads exposed. So now, what I've got to do is that's still moving. That's the two broken pieces moving against each other a little bit. That's going to happen until I get this all tightened up. And then of course when I'm actually running the machine and using it, the drawbar will be pulling the collet up through here. That'll also pull this together. Yeah, I know. Not the greatest idea, but it is what it is. Now I gotta put in my, at this point before I forget, I want to put, well, how do you like them apples? Just realized I can't put I forgot to put the R8 collet retaining pin back in. I can't put that in unless this is pulled out. Okay, here's my pin. Pin is held in place by this ring. This ring has a groove on it that's closer to one side than the other, and I did notice in the video when I took this out that the groove end faces up. So that's gonna go like this. And this goes back up in here. Now this can go on. Alright, the battery's going dead. What I do is I put in this this locking ring. I tightened it up tight enough so that I don't have to worry about that falling out, that bottom bearing pack falling out anymore. I'm just going to put this shield in the top here, and then I'm going to have to work on making a wrench to, I got a new spanner nut because that one's all chewed up. I'll have to make a special wrench. Hi everybody, last night I was down here working on the Wells Index mill and the battery on the camera died, but I wanted to get a couple more things done. so I didn't end up filming those. So I thought I'd just do a brief recap of what I did last night before I continue with working on the mill today. So I've gotten to the point where I am now ready to reinstall the quill assembly and the quill and spindle assembly back into the milling machine. I worked on it last night, and one of the things I had to do was I had to fashion some sort of an adapter or tool to tighten the spanner nut on the top here. And those of you who saw me take that apart know that the problem is the spanner nut is down inside the top of the quill here. It's a little hard to get at, and then of course you've got the spline shaft is actually in the way. I've actually got the drawbar in here now to hold this all together, but this is actually the nut that I removed, and the way that I ended up removing it was I used a punch at an angle, and I was able to just catch the edge here and tap it with a hammer and get it to rotate a little bit, and then reposition the punch, tap it, and that kind of really buggered this this nut, and it already had some damage on it, so it looked like somebody had already had this apart. So what I did was, when I had originally taken it apart and seen how I really kind of screwed this up, a while back I had ordered a brand new nut. This one came in, this is from L&N Enterprises, and this is an N07 bearing locking nut. It's actually it's a pretty common, I guess, in industrial applications for bearings, it's a common nut. So these are readily available. What's not readily available is the socket that fits this. There's a company in Rhode Island that apparently will make the socket for you to fit this specialized socket, and the irony is that it's like $200 or $300 for that one socket. So you can forget about me buying that. And to make matters worse, I believe it's a regular socket, meaning that, you know, the top is only going to have a hole for the ratchet to engage, which is not going to be any good for when you get to slide it over a long shaft that's in the way like this. So the actual correct socket that would work on this would have to be a socket that could slide over the spline shaft, have the lugs to engage the nut, and then have some way to put a wrench on the outside of it to turn it. So what I ended up doing was I ended up taking that thin-walled pipe that I picked up for $1 just a couple of days ago, and using the new nut as a guide, I marked out areas on this piece of thin-walled pipe that I wanted to grind away to in effect leave for tabs. And after I did that, I then used a file and fine-tuned the tabs to the correct size. The problem is the diameter is not quite right on this pipe, but I was able to bend these tabs out and get this to engage well enough so that I was able to then slide this over the spline shaft, grab the outside of this with a pipe wrench, and then I wrapped this spline shaft to protect it and grabbed it with a wrench to keep it from moving, and was able to tighten that locking nut, and I believe it's plenty tight. Now at this point I want to bring up another little interesting factoid. On the Bridgeport milling machines, they use a similar locking nut to this, and what they have is they have under this, they have a special washer that has these little tangs on it, like a star washer almost, and this is an N07 lock nut, so you would use a W07 washer. Well, the way the washer works is there's one tang on the washer that's supposed to sit in a groove, and then when that sits in the groove, the washer can't move, and then when you tighten the nut, you bend whichever tab is closest to one of these slots into the slot, and that effectively locks the nut from being able to loosen. So that's what they got on the Bridgeport. Well, when I read the disassembly spindle removal instructions for this Wells Index in the manual that I got offline, it also mentions the washer. which is kind of interesting because I looked and this shaft does not have a groove for that washer to go in. In other words, that threaded area that the nut actually threads onto is solid threads all the way around. There's no groove there. There's a groove up here on the spline shaft, but that's not where the washer would sit. So when I took this apart, there was no washer, and I kind of wondered, I wonder why there's no washer. Well, there's no washer because there's no way for a washer to be captive. Furthermore, it turns out that apparently on some of these machines, and I think on later machines, they actually don't use this nut. They use a snap ring. So that's kind of interesting. So apparently the snap ring would be in a fixed position in the groove, and then you would have to adjust that other spanner nut, bearing retaining nut that's on this side of the pack to actually get your to tighten it all up. So I don't know, that's kind of, just thought I'd mention that. Okay, so then tighten that all up. Once I get that tightened up, I wrap this in a cloth to protect the rack here, and I tighten this in my vise. My vise isn't bolted to the bench, but that still gave me enough holding power so that I could go to work on really seriously tightening up this retaining nut in the bottom here. And the way I ended up doing that was, remember, this is the type of spanner that I want to use for this, but this is the wrong size. It's too small. So since I didn't have one of these, I figured, well, I could make one of these. But what I found was, I found that these pins engage the holes perfectly. So what I found was that if I basically, turn this a little bit, if I put it in like that, and then I bring this down around here so the other pin is resting on the nut, I actually can turn it. And then I used a hammer and I tapped on this to get this really tight. And I believe it's plenty tight. Now, the next thing I want to mention is how it sounds. After doing all of that, removal of all the bearings, cleaning them meticulously, repacking them with new grease, and then reassembling everything, I'm a little disappointed that this still sounds, it sounds better by far, but it's still a lot noisier than what I would expect. So, unfortunately, I get a feeling I'm still going to have plenty of noise coming out of this spindle when it's at speed. But at this point, I think it is what it is. So what I'm going to do is I'm going to reassemble the machine. I'm going to try and see how much run out there is on the spindle. Take some test cuts. And if I'm getting a decent finish out of the thing, and I don't have a lot of run out, then I'm going to run this thing until the tires fall off, as they say. Because I also don't know whether or not this broken spindle that's being basically sandwiched and held together by the drawbar and the collet, whether or not that's going to really be able to stand up to heavy cuts. We're going to find out. So, it's Sunday morning. I just wanted to get this recap done, and then after breakfast I'll be back down here hopefully, and we'll go to work on putting the mill back together. And if we don't have too many interruptions and too many other things on the honeydew list today, I might even be making chips by this evening. Alright, so I'm going to install the quill assembly back in the mill here, and the first thing I need to do is I need to deal with the clock, or the spring that's inside here. So what I want to do is I want to actually rotate this 3 times. 1, 2, well, actually it's 2 times. 2 times. Alright, so I rotate this 2 times. Now if I let this go, this thing's going to violently go and possibly damage the clock spring that's in there. So now, to make my life easier, I want to keep this I should have hooked this up first. Alright, here we go. Alright, I'm not sure if this is going to fit in with the drawbar on, but we'll give it a try. The other step that you didn't see me do is I reinstalled the little tiny Allen set screw right here where my thumb is. That's the set screw that helps keep this ring locked. So I got to get this in. Of course, we want the rack teeth. I cleaned up this rack, and there were a couple of little nicks here and there in the rack. I hit those with a little bit of file and mostly just with a stone to clean them up so that they're nice and smooth. Second set of hands for this operation would be helpful, but I don't have that luxury. It's a tight fit. Alright. There we go. Alright, so I push it up to that point. Make sure my alignment's pretty good. That's it. Alright. Now I can reinstall this little block. Alright, so I cleaned up this little block before I reinstalled it, and of course the question is, does it go in this way or does it go in this way? And that is answered for me by the fact that there are three little marks right here. Little ghost marks right there. And they actually correspond with three little marks that I can see on the quill. So I know that this actually goes in like this with this block, this protrusion up top. So I'm going to rotate this down just because this handle's kind of in the way to get this block in there. And this time I'll mention that you definitely don't want to overlook this step and forget to put this block back in, because if you forget to put this block back in and somebody comes along and pulls the quill down, like I'm doing right now, if they pull down too far, the whole quill could release and drop violently onto your table, and at the very least break your cutter or end mill or whatever you've got in there, and possibly do even worse things. There's a little cutout area in the quill that this actually sits in. But you could still put this on backwards from what I can see, inadvertently. It's not correct to put it on backwards, I'm just saying that you could make the mistake of doing that. I don't see what would stop you. So I'm going to lock the quill down at this position here just so I can have two hands. Well, yeah. Alright, now there's a second part that goes on here, and that's the actual little vernier, I think they call it. And I think if you put this block on backwards, probably when you go to install your vernier here, you're going to quickly realize the mistake you made, because this is the scale on this side, and this is the little scale on this side, and they have to line up against each other. So if this was on completely backwards, then this would go on, and this scale would be facing the threads over here, and that's not what you want. You know what? I'm going to clean that up. That was just kind of dirty, gummed up with a combination of machine oil and dirt. Machine oil and dirt, over time they mix and make this kind of gummy mud. That's what that was. Alright, so now this has got the little thumb screw because this is adjustable. So if you want to zero this, that's how you would do it. So now, this will stop my quill. That's the other way. If the block was in backwards, I don't think the stop would work correctly. But I can set my stop. Oh boy, somebody's been eating their Wheaties. Whoever tightened this last. Well, I'm not going to mess with it now. I don't need to. Okay. That's nice. Now I think I'm going to tilt the head over because it's going to make the next bunch of operations a lot easier for me. I don't have to worry about really supporting this too much while I'm doing this because the center of gravity is much, there's a lot less strain on that worm gear because I don't have the whole casting up here and the motor and everything on there. Just kind of holding it a little bit just so it doesn't slam against the worm gear because there is backlash in that worm gear. And I am going to tighten it again. Just a couple of nuts this time. I just realized that I didn't have the camera angle correct. I had zoomed in. Now you guys have seen me tilt this a bazillion times. Let's reposition the camera angle here. Alright, so I have 2 blocks of wood on the floor here, 1.5 inches thick, giving me 3 inches of extra height, making my life a little easier. Actually, I don't even need them, but there we go. Alright. Can you hear that? Still noisy. Oh, look at that. Grease. Apparently somewhere down in there was a lot of grease that I hit when I was putting that back up. Oh, my hand's dirty. What the heck is it? Okay, next thing to go back in is this assembly here that I put the new bearings in. Ah! See, I remembered I had to take the drawbar out before I could take this off, and now I know why. Because this spacer on the top here, it blocks the tops of the splines so that this can't slide on. So I've got to take the drawbar back off. I think I didn't put that too tight. Because the ability of this part to slide up and down on this spline shaft is going to be critical to, well, the proper operation of the quill, but also how well or poorly, be that the case, that this shifts in and out of the drive. And that's moving up and down on that quill, no problem. Where I am seeing it being a little bit of an issue is it's okay, now it's gone down inside the head here, so I can see that I'm going to want to grease the splines, and then I'm going to want to grease this outer surface right here, because I still don't see how oil would get in there, unless again by design the oil's supposed to literally just kind of drip down in here, collect. It looks like that's what happens. Alright, I'm going to reevaluate the anatomy of this oiling system on this thing because it's still bugging me how that stuff gets lubricated. And so I'm going to try and figure it out. Because I know when I lower that quill, it's got a nice coating of oil on it. So the outside of that quill assembly is getting oiled somehow. So oil's getting into this head. The only place for oil on this head is right here. Now I do know that in the manual it does say to lubricate the spline shaft, you're supposed to lower that quill all the way down until the splines are exposed and grease it through there. So I'm confident about the idea of greasing the spline shaft. I'll double check that just to make sure it wasn't oil, but I'm almost positive it was grease was what they called for on that. But as far as oiling this system goes, I had already determined that this little oil cup right here actually goes to this little tube that's sticking down right here. Then I had thought I had determined that this lone hole down here at the perimeter was where that stuck through, but I just noticed that when I put that in position there, that, well, I guess that alignment is, yeah, that's right. Yeah, that's what I figured out before. Okay. Seems like forever since I worked on this. So that's how that goes on. So I know that where that outer hole is going to correspond to where that oil's going to drop in on top of the head. Okay, so now I put the disc in here, and of course I've got to figure out where to rotate this to, and I just looked, and here's the front alignment pin, and this oil cup is between the number 1 and number 2 screw holes right here, and it's much closer to the number 2, so it's right about here is where that oil cup sits when this is together. So that little rod, does that line up with the oil cup? Yeah. Well, yeah, so the oil's dropping in right through here. So where's that go when it falls in there? Well, the first thing it does is it drops onto this big gear. Okay? It drops onto this big gear. Then, I don't know if it gets slung around by this gear. Maybe. But also, some of it is going to fall through these holes. Alright, I'm going to reposition the camera so you can see what I'm looking at.